When you're working in the cloud, you tend to build your networks like these separate, secure little islands. But you know what happens when those islands actually need to start talking to each other? Today, we're going to dive into how you can connect private networks on Google Cloud. We'll start with the simplest fix and work our way up to the most powerful solution, and most importantly, understand the critical trade-offs you have to make. Let's get into it. So here's the problem basically everyone runs into. Let's say your company has a bunch of different teams, right? You've got your dev team, your production environment, data science, and you've done the smart thing by putting each one in its own isolated virtual private cloud, a VPC. That's fantastic for security, great for organization. But now, your development environment needs to grab data from a shared database that's sitting in another VPC. How do you link them up privately and securely without just throwing everything out onto the public internet? And look, this isolation isn't a mistake. It's totally by design. Big companies create these separate VPCs for really good reasons. You want to isolate your dev environment from production, you want to manage billing for specific projects, and you definitely want to create really strong security boundaries between them. But this separation, as great as it is, creates this new challenge. How do we get these isolated workloads to talk to each other securely and privately? Okay, so the first and most direct answer to this problem is something called VPC network peering. It is the most straightforward way to connect two VPCs, period. The really crucial part here is that it lets resources in each network talk to each other using their private, internal IP addresses. All that traffic stays right on Google's own high-speed, secure network. It never, ever touches the public internet. And doing it this way has some huge advantages. First, latency. It's incredibly low because you're riding on Google's private backbone. You're not out there fighting for bandwidth on the public internet. Second, security. It is way more secure. Your services aren't exposed with public IPs, which just shrinks your potential attack surface dramatically. And finally, it's cheaper. Sending data out over the internet costs more than keeping it all on the private network. For these simple connections, it's a total win-win-win. The easiest way to picture this is pretty simple. Imagine you have two completely secured, locked rooms. All VPC pairing does is build a private, locked hallway that connects only those two rooms. That's it. Simple, direct, and really secure. But, and this is a really big but, as your cloud environment starts to get more complex, that simple hallway model, it runs into a major wall. And understanding this one limitation is absolutely key if you want to design a network in Google Cloud that can actually scale. This right here, this is the official line straight from Google's own documentation, and it is the single most important thing you need to remember about VPC peering. It does not provide transitive routing. Okay, so what does that actually mean?
Right, let's just break down what this non-transitive thing is all about. It's a pretty simple concept, but it has enormous implications for how you design your network. Okay, take a look at this. Let's say VPC A is your development network. You peer it with VPC B, which might be a central hub for shared services. Cool, A and B can talk to each other. Now that same hub, VPC B, is also peered with VPC C, which is your production network. So B and C can talk. Now you would naturally think, great, my dev network A can talk to my production network C by just going through the hub B, right? Nope, wrong. That connection is completely blocked. The peering relationship doesn't get passed along. It's not a chain.
And this is why that one little rule matters so much. That standard hub and spoke architecture that everybody loves, where you have a central hub connected to lots of different spokes, it just flat out doesn't work with peering by itself. Your spokes can't talk to each other through the hub. And if you connect your on-prem data center to that hub, that connection can't get to any of the spokes either. This isn't a bug, by the way. It's a very intentional design choice in Google Cloud that forces you to be more explicit about how you handle complex routing. So, if that simple hallway we talked about can't build a complex interconnected network, what's the answer? Well, this is where Google's more advanced tooling comes into the picture. It was designed specifically to solve this exact non-transitive problem and let you build something truly powerful. Let me introduce you to the Network Connectivity Center, or NCC. This is Google's modern answer for building real, functional hub-and-spoke networks. It's not just another connection. Think of it as a central command center for your network, designed to manage and simplify all the complex routing between your VPCs and even your connections back to your on-premise data centers.
So if VPC peering is that simple hallway between two rooms, then Network Connectivity Center completely transforms your hub VPC into something more like Grand Central Terminal. It becomes a true transit station that intelligently routes traffic between any and all of the spokes connected to it and back to your on-prem networks, all through one single manageable hub. So how exactly does NCC fix the peering problem? Well, first, it explicitly enables that transitive routing we were talking about, so all your spokes can now communicate with each other through the hub. It also lets you have just one big, powerful connection back to your on-premise data center, like a cloud interconnect, and you plug it into your hub, and then every single spoke can use it. This makes management so much simpler and can save a ton of money. It just turns what could be a messy web of connections into a clean, scalable architecture. Okay, so now we get the two main options, right? We have peering and we have NCC. But the big question is, when do you use which one? And look, this isn't about one being better than the other. It's all about picking the right tool for the right job. So let's lay out a really clear framework to help you make that call. This table is basically your cheat sheet. It really brings it all home. Use VPC peering when you have a simple, direct one-to-one connection you need to make. It's fast, it's easy, and it's perfect for that scenario. But the moment you have 3 or more VPCs that need to talk, or you need to share a central on-prem connection, NCC is your answer. It was built from the ground up for transitive routing and for scale. And check out that last point, too. With peering, your IP ranges can't overlap, but NCC can actually handle that using a neat feature called Inter-VPC Net. For a huge company, that flexibility is a really big deal. So at the end of the day, the choice really boils down to this one question. Are you just building a few simple hallways between some adjacent rooms? Or are you trying to architect a fully connected city for your cloud infrastructure, complete with highways, interchanges, and a central transit hub? Understanding the difference between these two tools is the first and most important step to building a network that doesn't just work today, but one that can actually grow and scale with you tomorrow.